All right, so today I've got just a little bit of time, probably about an hour, maybe less, and I just discovered some new nodes in Blender that are going to do exactly what I want them to do. So let's get started. So what you may have remember is that for a while I was running into issues with sampling volume nodes. I couldn't figure out how to get the textures right. So we are going to today use something that the Blender developers have added in a recent version. So I want to start by showing you I'm using Blender 4 Alpha, 4.4 Alpha. And what you can do is you can go down into, let's see, which one is it? It's interface, and you'll see here there's developer extras. If I turn that on and off, this is in the preferences under interface. And here, let me switch this over to the upper right. Turns on and off this right here. So if I go here to experimental, I'm going to use the new volume nodes. So that'll be fun. All right. So next thing I'm going to do is I am going to create a VDB. Let's see, where do we have this? All right, so let's take a look at this. Now, the thing about this is I can't actually remember, did I get all the grids in here? Well, it doesn't matter too much. All we really need is we need this VDB file. So now let me go ahead and add my VDB file here. Add volume. There we go. Import open VDB. It's in BlendYT. Galaxy.vdb. So let me hide my cube. There's my Galaxy.vdb. You'll see there's a galaxy here. But again, I'm not the best with VDBs, so you can see that they're not, they overlap, but it's not actually combining them in the images. So let's take a look here. There's my level 4. You can see the density is all in there. All right, so let's go to level 0. You know what? Let's do level 4. Okay, so now let's go back to our cube. We will render that again. Let's disable galaxy volume. Let's go to our geometry nodes. So we've got our group input, group output. Let's delete that. So we've got our mesh size. So now we've got a grid. All right. So here's what we're going to try doing. We are going to come up with a 32 by 32 grid. All right. And now let's take our attribute. We will read our position. All right. Now I want to view this. So I guess I can't view it, huh? Okay. We are going to take our position, and then we've got this sample grid index. So we're going to take our grid index, and we will set a named attribute. So store a named attribute here, and our named attribute will be value. We will store it on our mesh, and we're just going to put our value there, so it should be constant. Okay, so now we have a constant named attribute, and the value you'll see is 0 everywhere. Well, we don't have a grid. We don't have a volume to sample yet, so let's do that. So we've got our galaxy. Oh, am I misremembering? Let's get named grid. Yeah, there we go. Okay, name. Oops, I think we want level 4. And we're just going to sample based on the index. So object info. All right, geometry feeding into our volume. So now we've got level 4. Let's check what these objects actually have. Yeah, level 4, there we go. Can we drag that in? No, we can't. Object galaxy. So we're still getting zeros everywhere. Volume 9 grids, supported all types. Okay. Level 4 is our string. So let's add a viewer here. Volume grids. Huh. Still can't see anything there. Let's try this. Can't see anything there. We've got our sample, we've got our volume. Oh, right, of course, because they're in the absolute coordinate system. So let's see, I'm going to rerun this. Let's go back here. Maybe I can somehow see my grid. I can see the extent. I guess if I go to 0, then I should know for sure. So let's go back to level 0. Now this still has a value of 0 everywhere. That stinks. So it should be sampling my index at 0 everywhere. Or it should be sampling it at 9 for every single one of them. Well, that's a bummer. Let's see, volume. Okay. Now let's come up with a position. So this should, now when I move this, should change it, but it seems like it's not. Nope, it's not changing my value at all. So what's going on here? How come I can't seem to get my values selected here? I should be able to sample the grid. Okay, so there's my volume. Why is level 0 showing up there? Oh. Okay. So I'm definitely intersecting it now. Okay, so I should be intersecting it. I'm reading my position for the position at which to sample the grid, but I'm storing a named attribute and I'm not getting anything. Let's see if I can do a vector here. Value. Let's try this. Yeah, it's 0 everywhere. It's a real bummer. So let's take a look at the data. So I must be misunderstanding how I'm using this sample grid. Because I should be able to see my named attribute regardless of whether or not I'm actually doing any coloring or anything like that. So that's a bummer. Okay. Let's try it with something else. We'll do a volume cube here. Instead of doing this object, there will be my volume. Maybe that's the problem. Maybe I'm just not, maybe there's another level to the sampling that I need to do. So let's see. Got my notes over here. So Blender sample grid. So here is the development by Hans Goudet. That's what it looks like here. Now let's see, they reference it in other, where's the other reference? go. Here's another one. It's similar to the sample grid, but there is no interpolations, indices instead of positions. Yes, this is exactly what I'm hoping for. All right, so object info. They've got Suzanne, which is that. Position scale, separate XYZ, sample grid index. Right, this looks exactly what I'm doing, so that's starting to make me wonder if maybe there's something going on with the way that I'm sampling these. So that's a float, that's a float. All right, you know what? Let's see if I can instead create a single one, and I will just do all of it in log. So let's do this. I'll do a Python file, copy all of this. Now I can't remember if I actually ended up getting OpenVDB installed in my normal environment, so we'll have to figure that out in a minute. We'll load up Isolated Galaxy. We will save this one as single isogal VDB. GVDB is equal to VDB float grid. All right. GVDB. Galaxy with a capital G. Well, we'll deal with our transforms in just a minute. So now, G density, G VDB copy from array. And now what we'll have is we'll have a covering grid, CG equals ds.r, 256j, there we go, mp.log10 cg.d, ijk equals 0. Okay, so now all we've got here is we're creating it with, all right, so let's try. Right. It's been a while since I've built for Python 3.11. Rather just rebuild YT than install OpenVDB on this. But I guess we'll have to see how well that works. Probably it won't now that I'm seeing it, but because I haven't kept any of my dependencies up to date. Come on, build already. All right. Alright, well, let's just go back to this one. Now it's Mamba install Pi open PDB. Let's see how that works out. Alright, let's see if it'll install OpenBDB for me. If not, I guess the other option that I have is just create it inside. You know what, that's probably what I should do. So let's see, copy. Let's go into Blender. We will create a script. Actually, yeah, that doesn't work. All right, so create new file, Python file, import Pi open BDB. Hold on, am I just doing the name wrong? All right. It was OpenBDB, not Pi OpenBDB. And this isn't going to work either. Now it should. Okay. Let's see what this looks like in OpenBDB. That's interesting. Huh. It must be auto-compressing it. All right. Let's go back to Blender. Let's delete that. In fact, we're probably going to want to wipe this out. Oh, it's got all those, because I moved it. Let's see, object properties, I want to reset it. Okay. Now let's import our volume again. Well, that's enormous. All right, let's go back here. Let's check this out. I think what I need to do is set a transform. So let's come up with a transform. Here, let's put this up here. BDB.transform. That should do it. I wonder why. Okay. Come on. Let's see. Do I have some data that's like sticking around here? Let's try that. Now let's go back to geometry nodes. Yeah, that looks right. Okay. Let's add a volume. What? Alright, well this is a little frustrating because it's not, so let's see, what is that? 1 divided by 256, 1 divided by 256, 1 divided by 256. There we go. Okay. Alright, so now we should be able to sample that thing. Let's get rid of that, get rid of that, get rid of that. Sample the grid. Object info, named grid. What do we call it? Galaxy with a capital G? Yeah, looks like. So the geometry here goes into volume. This is isogalaxy. That grid goes in there. Check that out. Great. Okay. So here is this. We'll do 256, 256, and this plane. We will transform it by offsetting it by 0.5 in the x and the y. Oh, no. 0.5 in the x, 0.5 in the y. Okay, and now if we move the z up to about 0.5, everything is still 30. It shouldn't be. Oh, because I'm just grabbing it from the position 0. Okay, read position. So now the background stuff should still be there. Oh, but it's not. It's still all there. All right. We'll take a look at that in just a moment. For now, though, we've got our value. It's being stored. Let's see if we can come up with a shading for this. Turn off isogalaxy. I'm also going to quick take a look here to see. CG mp.log10 CG density. Goes up to minus 24. So we should be seeing something that's at minus 24 somewhere in here. We just aren't. Let's see if I can does VDB print do? We'll do -lm iso galaxy.vdb. Let's see, does this give us min and max? Yeah, max value -24. Okay, this should probably be code density, but we'll come up with that in a second. All right, now let's go into our material. So set material, and we're going to read our value off. All right, we'll create a new material. We'll call this slice mapping. All right. We will read our named attribute. Why is it slowing down all of a sudden? Let's call it slice map. Okay. Attribute. From the geometry, the name is a value. We will get a factor. We will map the range there. Value from min -31 to -24.5. Okay, and now we'll do a color ramp. Let's go back to geometry nodes. And we will set this to slice map. Now let's view it. And it's the same everywhere. Okay. Oh, I think I see what the problem is here. Because the scale isn't set right. Let's try multiply, math, multiply, 256. Okay, so now we're getting some variance. And this actually needs to be a vector. Yeah, all right. So the translation here is the issue. There we go. Check that out. All right, that's fun. And so now, cool. All right, so now let's try another thing. That's neat. So now I'm sampling a volume. I had to scale the volume here. So let's see, domain size. Instances, no. We actually want this to be like, I really want the volume info here. So the grid is independent of the volume info. So I guess, what am I doing differently here? BDB create linear transform, voxel size equals that, IJK. I don't know. Why is the voxel size not working for that one? So there we go. So now in principle I can, let's try bump mapping it with that. Oops. Oh right, they're voxel centered, so I gotta also add 0.5. Well, now we've got an edge to it where it's all set to 1, but that's not amazing. I guess I'll deal with that in a minute. Okay, it's got to be just something with the way that the edges are being selected and getting the edge versus cell centering. So I can probably manage that, but let's try to finish up the what I wanted to do with the bumping. Okay, so we've got this. Okay, so now we've got this ramp. Let's do this displacement. Okay, well that's cool. So let's do first person mode. Oops, where did I go? Oh, there we are. Okay, so we've got displacement there. Let's try going into our renderer. We want this in cycles. Let's go into our material, and you see there's some artifacts there that's actually in the data. Alright, so volume, no. Viewport display, no. Where is it that I set the settings? Displacement and bump. Huh. falling into it. That's cool. Let's use the soundboard for a second and see what our favorite robot thinks of Hamdingers.
Nobody likes Hamdingers.
All right. Okay, so now this, once I can get the edges there fixed up, I think I'll be able to do this much less. You know what? Let's try to do that now. What happens if we just do 255? Nope, that didn't do it. So what if there, that, let's see, if we do this, there we go. Now we're actually starting to see just the stuff we want. Oh, one moment. All right. So now we're sampling our galaxy like that. This is cool. All right, let's get back to I don't know. This is just the coolest. I'm super happy. These volume nodes are incredible. I'm so glad that they are doing them. Let's try. Do I have? I can't remember. Let's get some color maps. Okay, those are already all installed. So let's install some color maps here. What? Okay, it's still installing that one. Oh boy. It's installing NumPy 2. I don't really want that. Oh well. Probably have to fix it later, but for now I just want to get these darn color maps in. And so what we'll do here, instead of doing a color ramp, we'll do an image texture. And we will do combine XYZ. So now let's go back to scripting. Everything should be installed. All right, so we've got all of our favorite images in there. Looks like a cool castle. We'll do algae because it's the first one alphabetically. Well, that doesn't look right. X and Y. So we actually want to sample at Y. Cool. Arbra. Apricity. It's one of my favorites. Doesn't look like much right there. But it doesn't look like much outside of there either. Kelp? No, kelp's no good for this. Dusk. Now, one thing we can definitely see here, and we can probably see it if we zoom in a little bit. You can see some of the discretization in the cells. Also, I don't know what's going on with the clipping. You can see the trilinear interpolation there. I bet if I go back to geometry nodes, did I do trilinear or did I do nearest? Regardless, I bet if we... Oh no, it's trilinear. What about triquadratic? Does that smooth any of this at all? Nope. Okay. Oh no, it did. Okay. Great. So this actually gives us what we need in order to apply the bump mappings on spherical shells. So now let's try, we will take we'll take all of this and let's see if I can add in my volume. Import h5pi. Just going to need h5pi for this with h5pi.file modes.h5 as f. I don't think I do this in my other repository. Nope. So I have a whole bunch of modes that are distributed across the sky, theta phi. F, we'll do /70. We'll say data is equal to that. G VDB equals VDB float grid. Do 70.0. We'll create a linear transform. Now our voxel size here is going to be, we're going to leave 1 in the Z, but for this one and this one, because Z is going to be our time, and we'll have it as frames. For this one, we will have, let's see, theta phi. So that goes 0 to pi. So that's np dot pi, 1.0 divided by np dot pi. The next one is 2 divided by np dot pi, and the last one is 1.0. I don't think I want that dot grid thing. We'll do copy from array, ijk equals 0, 0, 0. This is modes to BDB. So now YT blend YT ln-s tilde dxl gwave modes.h5. Oh, I already copied it. Modes to VDB. Alright, let's get rid of that for now. We'll do the transforms inside. Type error. Oh yeah, because it is complex. We can't have complex. Okay. So now we've got modes.vdb. Alright, so we've got our new one. Let's get rid of our cube. We're going to instead create an isosphere in just a minute. Geometry nodes, we will add a volume. You'll see it's gigantic. Let's clear that. We will also not render it. Now let's add let's do a UV sphere. Okay. So now let's do something simple. Object info modes. What did I call it? I called it 70.00. Yeah. Get named grid. The volume there. Okay, so now we've got our volume and our grid. Sample grid. And now we need our spherical coordinates. Which one was the sphere perturbations? Yeah. All right, I'll just do it manually. So we've got this. Now let's get our positions. Okay, separate X, Y, Z. And now for we want theta is arc cosine of Z over R. Let's rename this one. Okay, radius Z over R. And this one is arc cosine. Okay, so there is theta. Now phi is arctan to y and x. Okay. So now we've got our theta, phi, and r. Let's rename these. So now let's combine XYZ, R, theta. Hold on. It's stored in theta phi, isn't it? Wait, hold on. Let me make sure. It is stored in theta phi. So theta phi, and this is going to be brane. Okay, so now we will store that. Store named attribute, store a vector. There's our value, chord. Actually, don't need to do that at all. What we need to do is we need to do sample of volume. So we need to multiply this by our dimensions. That's frame. So we multiply this by the vector 200, 100, and then it's already going to be in the right units. So we sample our grid at that position. Then we store named attribute, value, name, value. And we'll do this on our geometry. Let's take that. Geometry. Okay. So our value is 0 so far. This should not be 0 everywhere. Let's do attribute statistics. So Z goes up to 600. X goes up to 100, like I thought. Y goes to 200, so it should be sampling right. Let's try scaling it and then logging it. Okay. Do NPABS there. Why is it? Oh, because I've got too many arguments. There we go. Yeah, it's always going to be super small regardless, and it's a floating point number. So let's do data equals np.log10 data, data minus equals data.min. OBS keeps saying that it's disconnected, but it seems like Twitch doesn't think that we have. Anyhow, let me finish this up real fast, because it seems like my connection's getting a little flaky. Let's go back here to my sphere modes. Okay, and now this should, I should be sampling and storing values. Okay, let's go back here, because it does scale weirdly. Yeah, frame 427. Let me store some attributes on this. Actually, I'm just gonna, let's set a vector value here to, we'll input a constant vector of x of, see, x 150 and 425. Still 0. Okay, well, once again, my modes and sphere have started confusing me, so cp modes.vdb modes2.vdb. Let's change this. Okay, so now modes2.vdb is there. Let's turn that off. Let's look at my sphere. Value is still being sampled at 0. Should be showing me something at that point. Oh, I'm not choosing not. Alright, well that was once again another silly error. Let's get rid of that. Let's get my vector back in there. Okay, so now at least, yeah. Alright, we're seeing something here. Okay, let's take my UV sphere, subdivide surface. Let's subdivide it at 4. Set shade smooth here to true. Okay, and now let's set a material. We will just have our standard material. Let's go on over to shading. don't have anything yet. So attribute value, and let's, I don't know what happens if we set it to color. Nothing. All right, color ramp. Okay, so let's go back to geometry nodes. Set that there. Still not seeing much of anything here. So I'm starting to think perhaps I'm sampling it wrong. Or I'm setting my, so I'll store another named attribute on this, and that named attribute will be here. Call it position, and let's stick that in there. That's strange. I'm scaling it, but it's not. Oh. Aha. You know what? Let's not do any of this multiplication stuff. Delete that driver. And instead here, instead of the multiply, we will just do a mapping. Because that's really what we want to do anyway. Vector from min negative pi over 2 to pi, to negative pi. No, yeah. Is it? And then 0 to 1, to 400. To min 0, 0, 0. Max 100, 200, 600. So now we'll store that here. That'll be 0 to 2 times pi. Let's try that. From max 600. Okay, now this. All right, you know what? We are going to store a ton of attributes on this thing. Selection. Yeah, we'll do that. Store a vector. Store my geometry. Name raw pos. Okay, so now we've got that. And now let's do attribute statistic. Link to viewer. Oh, the attribute. Named attribute. Do vector raw position. All right, looks like it goes to pi in that one. Negative pi. All right, so this one goes 0 to pi. This one goes negative pi to pi. Okay, so now get rid of that. Okay, that's looking more like it. Let's take a look at pause here. Link to a viewer. No. Min. Okay. Max. Good. Okay. All right, so now we've got our material. Fading that there. Let's go back to our shading. That's interesting. Okay, still not seeing much here. But I should be. Look at that. So let's go back to, am I setting the material right? No, I don't think I am. Ha! Always gets me. Okay, now let's take our frame. Okay, and with that, I think I'm going to call it, because I think I've got my shading all set. So, thanks for joining me.